Hello friends, welcome you in Research Needs. In this video, we will see today study of analgesic activity with the help of tail flick apparatus. So we will enter into the Ex-Pharm software. So here we will see this type of interface. Now we will click virtual practice through tail flick apparatus. We will click this tab. Now we will enter to start experiment. So now you can see here the equipment in which animal is kept restrained and its tail is kept aside, and here you will see the radiant heat source. From that, when you will start, it will give a heat, a measured heat. We will focus on this tail. So when we will start the experiment, that time it will produces the heat, and as per mice or rats body pain sensation tolerability, it will flag the tail. We have seen the equipment. Now we will see the introduction. The tail flick test is a test of pain response in animals similar to the hot plate test. It is used in basic pain research and to measure the effectiveness of analgesics by observing the reaction to heat. It was first described by D. Armour and Smith, 1941. So now we have seen the little introduction about the equipment. Now we will go and see the principle. So here we will see the principle. Analgesic drug increases pain threshold, ability to tolerate a pain stimulus. Means here the drug which are used to relieve pain sensation are known as a analgesic. So that we are using here, and it is saying it increases the pain threshold. Means suppose you administered analgesic drug and came across accidentally to touch some heat objects. That time you feel less pain, or you can bear that pain with analgesic, and this effect can be estimated in animal model of analgesia. To induce pain, following type of stimuli can be used. So to induce pain to the animals, we are generally using this method. So radiant heat projected on tail, means the whatever we are doing here, and paw or shaved skin. Sometimes we have to remove this fur, and there we are focusing the radiant heat, or sometimes in paw. Cold stimulus applied through a cold plate. Sometimes a cold plate we are means we have to reduce its temperature below 0, and on that we have to place the animals, or we have to put its tail on that. By that we are also, and after sometimes it will flick its tail. So like that we are also using cold stimulus. And mechanical pressure on tail, paw apply using a clamp. We have sometimes we are using a clip, means a iron clip we are applying on the tail. After little time it will start shaking its tail. In such situation, we are recording the time duration and how much time it taken to flick the tail, that we are recording. Electrical stimulus on both pulp. Sometimes we are giving shock to the tail, and chemical stimulus formalin. We have to apply the formalin on the tail. It also produces pain. The time taken by the animal to reveal pain cessation through the vocalization or paw licking or effort to escape the pain stimulus, withdrawal of the body part on which pain is inflicted, paw or tail, is determined. So we have seen in a hot plate, when we are applying heat to the plate, hot plate, the animals was start jump, or sometimes start licking its hind limbs. So likewise here also, when it feel it animal perceive the pain sensation, then it try to move its tail. So the analgesic increase the time taken by the treated animal to reveal the pain cells. It means if you have taken analgesic, it will increase your pain bearing capacity than the person who have not taken the drug. That here in this experiment we are going to see using two animal groups with analgesic and without analgesic. How much time analgesic has increasing when applying heat radiance to the animal tail, that we will see in this experiment. So now we will see next experiment part. So while we clicking, we found instructions. We will read it speedily. The interface shows two groups of mice containing 6 mice in each group. So we have to divide all animals in two groups. In each group 6 animal will be there, which have been randomly selected and allotted two groups, and select the groups to be treated with the study drug and vehicle. Means we will use here morphine, so study drug will be the morphine. Administer the respective treatment to individual animals by intraperitoneal routes. So here we have to give the drug by oral route or by as per the drug requirement. So click the mouse to put the selected mouse on tail flick apparatus. It is saying here we are using here software, so we have to click the animals to keep the animals on the tail flick apparatus. Record the response time at which the mouse move the tail, and when the mouse move its tails after applying the heat, that time we have to record. The mice in the test are injected morphine 10 mg per kg oral, and the mice in test are injected morphine 10 mg per kg, and the mice in control are administered with the vehicle in the same volume. The response time is recorded after 1 hour of drug administration. So here we have to give the drug orally or IP dose as per the analgesic drug type, and after 1 hour we will start the experiment. We will follow these steps. For step 1, select the animals to be treated with vehicle or drug dependent upon its group and administer the respective treatment. So we will select by clicking one by one. First we will select vehicle treated group, and then we will start treatment to drug treated group. So after 1 hour of treatment, load the mice on tail flick analgesiometer. So after 1 hour of dose, whatever it may be, IP dose or oral dose, after 1 hour we will start the experiment and we will keep the animals on analgesiometer. So now we will see the experiment. So here you can see the number of animals. Now we will administer the drug to both group. To vehicle treated we will give saline, and to the drug treated we will give the oral dose of morphine. So here in video it is showing IP dose. So now animals are divided. So now we will screen one by one animal. So we will click the first animal first. So here it is showing 8 seconds to flick its tail. So we will write here 8. We will check another animal likewise. So while we are applying the heat, it has taken 10 seconds. We will select the next animal, third one. It has taken 13 seconds. Now we will check next animal. So every animal has tolerance different, so accordingly it is showing. So here it is showing 9, so we will write here 9. We'll check for another animal. So it's a fifth animal, so it's showing 13 for tail flick. Now we will go for next animal, last animal from vehicle treated. So it has taken 14 seconds. So now it's going to move 14 seconds. So next we will try now drug treated. So we will see how much time it is increasing. Now we will click to the first animal. So for the first animal it has taken 13, so we will write here 13. We will click to next animal. Here it has taken 15 seconds, we will write here 15. We will click to third animal from drug treated group. So this animal has taken 16 seconds to flick its tail. Now we will click fourth animal from drug treated group. It has taken 11 seconds. This is a bit surprising. Now we will go for next animal. So here the fifth animal result is 13 seconds. Now we will go for last animal from drug treated. So it's a 14. It has split the tail. Now we have completed both group screening and we got the result and we have written the reading. So now we will see the observation and compare both results. So here you can see the response time. Here average is around 11 seconds and here it is increased by 2 seconds, 2.5 seconds more than the vehicle treated groups. So here response time increase after the animal is treated with morphine. So bearability for the pain is increased in morphine treated group. So now we will see the conclusion. Increase in the average response time in drug treated mice shows that the pain threshold is increased in drug treated mice. So how is the video? Please do comment. Thank you for watching Research Needs. Thank you very much.